How are you everybody? How are you today? This is the first lecture in our semester about the course of advanced mathematics. This is the first lecture for the fourth year statistic English section. Banha University 2020. We will start our course by sequences and series. This is a brief introduction or motivation. We encounter sequences at the very beginning of our mathematical experience. The list of even numbers, as we know, 2, 4, 6, 8, 10 and so on. And the list of odd numbers 1, 3, 5, 7, 9, there is no any problem. But we must know that the sequence write down in a specific order. As we stated, 2 plus 2 equal 4, 4 plus 2 equal 6, 6 plus 2 equal 8, 8 plus 2 equal 10. And odd numbers, 1 plus 2 equal 3, 3 plus 2 equal 5, 5 plus 2 equal 7, 7 plus 2 equal 9, and so on. Our examples, we can predict what the 10th term of each sequence will be just by using common sense. Another sequence of great historical interest in the Fibrocal sequences 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 100, 40, in which each term is the sum of the two preceding terms. For example, 55 equal 21 plus 34. In this case, it is somewhat more difficult to predict the 20th term without listing all the previous one. So that if you want to know that 20th term, you must write down all the preceding terms, so that sequences arise in many areas of mathematics, including finance. For example, we can invest $10,000 at an interest rate of 5% per annum, as was stated in the financial mathematics in first year. Compounded annually, and list the sequence consisting of the value of the investment each year. So that you must know that sequences must be written down in a specific order. This is the pure definition. This is the main definition for the sequences. Sequences must be written down in a specific order, as we stated in the first of this lecture. So that you must know that the definition of sequences terms like 2, 4, 6, 7 terms is a numbers. The terms in a sequence is a numbers. This number must be stated in a specific order, so that if you write down any numbers in a specific order, it must be called sequence. An infinite series is the formal sum of the terms of an infinite sequence. For example, 1 plus 3 plus 5 plus 7 plus 9 plus ... This is called infinite series. Infinite series consists from infinite sequences. If the series formed from the sequence of odd numbers, we can spot an interesting pattern in this series. The sum of the first two terms is 4, the sum of the first three terms is 9, and the sum of the first four terms is 16. So we guess that in general the sum of the first n terms is n to the power 2. For a given infinite series, we can ask the question, can we find the formula for the sum of the first n terms of the series? Does the series have a limit? That is, if we add the first n terms of the series, does this sum get as close as we like to some number as n becomes larger? If it exists, this limit is often referred to as the limiting sum of the infinite series. In this module, we examine limiting sum for one special but commonly occurring type of series known as a geometric series. Sequences and series are very important mathematics and also have many useful applications in areas such as financing, physics, and statistics. So that there is a very close between finite series and finite sequence, infinite series and infinite sequence, so that if the terms of the sequence is added to each other, it's called, if the terms of the sequence is added to each other, it's called a series. Sequences can be either finite or infinite. For example, if we have a sequence consists of 2, 4, 6, 8, 10. This is 6, 8, 10. This is a finite. There is no any other terms at all. But if there exists another terms like 2, 4, 6, 8, 10, and so on, this is called infinite sequences with 5 terms and so on. Counts without bound and is an infinite sequences. We usually use ... to denote the sequence continuous without bound. There is no any bound to this sequence. For a given infinite sequence, we can ask the questions. Can we find a formula for the general term of the sequence? Does the sequence have a limit? That is, do the numbers in the sequence get as close as we like to some number? If we can find the limit of the concept of the sequence, we must call it convergent, but otherwise divergent sequences. For example, we can see that the terms of the infinite sequences 1, 1 over 2, 1 over 3, 1 over 5, 1 over 4, 1 over 5, whose general terms is 1 over 10, are approaching to 0 as n becomes very large. This is called finite. No, this is called infinite terms, but it's called convergent because the limit go to 0. A finite series arises when we add the terms of a finite sequences. If we add the series to each other, 2 plus 4 plus 6 plus 8 up to plus 20, this is called series. It's the series formed from the sequence. So that if the terms of a sequence added to each other, it's called series. This is a content sequences. The list of positive odd numbers 1, 3, 5, 7, 9, and so on is an example of a typical infinite sequence. The dots indicate that the sequence continues forever without no last term. We will use the symbol a sub n to denote the nth term of this given sequence. Thus, in this example, a1 equal 1, a2, a sub 2 equal 3, a sub 3 equal 5. This is the terms of the sequence, and so on. The first term is a1 equal 1, but there is no last term. This list of positive odd numbers less than 100, 1, 3, 5, 7, and 9 is an example of a typical finite sequence. The first term of this sequence is 1 and the last term is 99. This sequence contains 50 terms. There are several ways to display a sequence. Write out the first few terms. Give a formula for the general term. Give a recurrence relation. Writing out the first few terms is not a good method since you have to believe there is some clearly defined pattern and there may be many much pattern presence. For example, if we simply write 1, 2, 4 and so on, then the next term might be 8 powers of 2 or possibly 7 lazy curve sequence, or perhaps even 23 if there is some more complicated pattern going on. Hence, if the first few terms only are given, some rule should be given as to how to uniquely determine definitely determine the next term in the sequence. A much better way to describe a sequence is to give a formula for the nth term a sub n. This is also called the formula for the general term. For example, a sub n equal to n minus 1 is a formula for the general term in the sequence of odd numbers 1, 3 and 5. From the formula we can, for example, write down the 10th term, since a sub 10 equal 2 multiplied by 10 minus 1 equal 19. This is the general form, the general term, the nth term of the sequence. By the general term, the nth term, the general form of the sequence, we can conclude the terms of these infinite sequences. Otherwise, anyone can write the sequence as he like. So that there must be a general form, a general term for the nth term of the sequence to write the sequence definitely. In some cases, it is not easy or even possible to give an explicit formula for a sub n. In such cases, it may be possible to determine a particular term in the sequence in terms of some of the preceding terms. This relationship is often referred to as a recurrence. For example, the sequence of positive odd numbers may be defined by a sub n equal 1, a sub n plus 1 equal a sub n plus 2 for n greater than or equal 1. The initial term is a sub 1 equal 1. And the recurrence tells us that we need to add 2 to each term to obtain the next term. The Fabbriconi sequence comprises the numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, where each term is the sum of the two preceding terms. This can be described by setting a sub 1 equal a sub 2 equal 1 and a sub n plus 2 equal a sub n plus 1 plus a sub n for n greater than or equal 1. This is all related to the general or the nth term or the general form of the sequence. Exercise number 1. Consider the recurrence a sub 1 equal 2, a sub n equal a sub n minus 1 to the power 2 plus 1 for n greater than or equal to. Write down the first 5 terms of this sequence. All the students must solve this exercise. The general term of sequence can sometimes be found by pattern matching. Exercise 2. Given a formula for the general term of the sequence 2, 4, 6, 8 and so on of even number, the sequence 1, 4, 9, 16 of squares. In these cases, we wanted to find the nth term, general term, the general form of these sequences. In general, however, finding a formula for the general term of a sequence can be difficult to consider. For example, the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, 34. We will discuss the history and application section how to show the nth term, the general form of the sequence is given by. This is a very surprising result. It is not even obvious that this formula will give an integer result for each n. You might like to check that this formula works for n equal 1, 2 and 3. Sequences can also be used to approximate real number. Thus, for example, the terms in the sequence 1, 1.4, 1.41, 1.40, 1.414 to give approximation to the real number square root of 2. Arithmetic sequence. What is the meaning of arithmetic sequence? We will limit our attention for the moment to one particular type of sequence known as an arithmetic sequence or arithmetic progression. This is a sequence of the form a plus d, a plus 2d, a plus 3d, where each term is obtained from the preceding one by adding a constant called the common difference and often represented by the symbol D. The difference denoted by D, the symbol D. Note that D can be positive, negative, or zero. The value of D may be negative, positive, or zero. Thus, the sequence of even 10, 2, 4, 6, 8, 10, and so on is an arithmetic sequence in which a common difference is D equal to. It's easy to see that the formula for the nth term of an arithmetic sequence is a sub n equal a plus n minus 1 multiplied by plus n minus 1 multiplied by d. This is an example. Find the formula for the nth term of the arithmetic sequence. 2, 5, 8, and so on. 107, 90, 80, 89. This solution a equal 2 and difference of c, so